Hi everyone, this is your math guru. In this video, I'm going to show you how to prove different types of quadrilaterals. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Starting with my parallelogram, if I have a parallelogram labeled A, B, C, and D. The first proof is for me to show that both pairs of opposite sides are parallel. So I'm going to show that AB is parallel to DC and AD is parallel to BC. What that means is I have MAB, that's the gradient of AB, is equal to the gradient of DC, and the gradient of AD is equal to the gradient of BC. The second option while proving a parallelogram is to show that both pairs of opposite sides are equal. What that means is I can prove that AB is equal to DC, and likewise AD is equal to BC. What that means is the distance AB is equal to the distance DC, and the distance AD is equal to the distance BC. The third option is you can prove that one pair of opposite side is parallel and equal. That is, you can prove that the gradient of MAB, or the line AB, is equal to the gradient of line DC. That shows that those two lines are parallel. And you can prove that the distance AB is equal to the distance DC. The last option is to show that or prove that the diagonals bisect each other. What that means is if I draw the diagonal of DB as shown and the diagonal AC as shown, it means that at the point M where they meet, they bisect each other. So DM is equal to MB, and likewise AM is equal to MC. So therefore, using the midpoint formula, you can show that the midpoint of AC is equal to the midpoint of DB. In all the options, option 4 seems to be the easiest because you're only proving the midpoint. Let's look at the second quadrilateral. To prove that a quadrilateral is a rhombus, you can prove that 1. Both pairs of opposite sides are parallel. That is, you try to prove that it's a parallelogram, plus one pair of adjacent sides is equal. A rhombus is a special kind of square that is like a squashed square. So all the sides of the rhombus are equal. To prove that it's a parallelogram, you can prove that both pairs of opposite sides are parallel. That is, if I tag my rhombus AB, C, and D, you can show that the line AB is parallel to the line DC. Likewise, the line AD is parallel to the line BC. You can prove that both pairs of opposite sides are equal, as shown. AB is equal to DC and AD is equal to BC. You can also prove that one pair of opposite sides is parallel and equal. So therefore, you can use any of the proofs of the parallelogram, but the one I will recommend is to show that the diagonals bisect each other. That seems to be the easiest. So therefore, if I draw the line or the diagonal DB as shown, and the diagonal AC as shown, they both meet in the middle, that's point M, and also what that means is that the midpoint of AC is the same as the midpoint of BD, and you need to prove that one pair of adjacent sides are equal. If you stop at showing that the midpoints are equal, you've only proved that it's a parallelogram. But if you add that one pair of the adjacent sides are equal, then you've shown that it's a rhombus. So you can show that the distance AB is equal to the distance DC. The second option is you can prove that it's a parallelogram plus the diagonals are perpendicular. What that means is where they meet, it forms 90 degrees. So the first step, you still need to prove that it's a parallelogram, and I can do that by saying the midpoint of AC is equal to the midpoint of BD, and the gradient M of AC multiplying the gradient of BD will give you -1. That shows that the line AC, that is the line AC, is perpendicular to the line BD. And there's two options. I'll stick with the second options because you're only showing the parallelogram and also showing that the two lines are perpendicular. For a rectangle, you can prove that one, it's a parallelogram. That is, you can prove that the opposite sides are parallel as shown. You can prove that AB is parallel to DC, or AD is parallel to BC. You can also prove that both pairs of opposite sides are equal. What that means is the line AB is equal to the line DC. Likewise, the line AD is equal to the line BC. The last option for the parallelogram, you can prove that the diagonals bisect each other at midpoint. So if I have the diagonals as shown, that's line DB and line AC, you can show that at the point M, which is the midpoint, they bisect each other. Plus, the one interior angle is 90 degrees. How do you show that? One, you need to show that it's a parallelogram as shown, and to show that one interior angle is 90 degrees, you can show that the gradient of AD, if multiplied by the gradient of DC, it will give you -1. You can also show that the gradient of AB and AD will give you 90. That can give you 90, and the angle at C is also 90 degrees. For the second option, you can show that or prove that it's a parallelogram plus the diagonals are equal or they bisect each other. So what that means is, if you prove that it's a parallelogram using all the options mentioned, then you can add that the diagonals are equal. And what that means is you need to prove that the distance AC is equal to the distance BD. And also note that the diagonals also bisect each other. So that means the distance DM is equal to the distance MB, and the distance AM is equal to the distance MC. So basically, a rectangle is a kind of parallelogram with the interior angles equal to 90 degrees. So you need to prove that it's a parallelogram and add that one of the angles is 90. or you prove that the diagonals bisect each other, or they are equal. Let's look at the last shape, which is the square. To prove that a quadrilateral is a square, one, you can prove that it's a parallelogram. What that means is the opposite side, let me tag the side A, B, C, and D. Opposite sides are parallel, as shown. That's the line AB is parallel to CD, or the line AD is parallel to BC. You can also prove that opposite sides are equal, and you can prove that the diagonals of the square bisect each other at midpoint. So what that means is you have the diagonals DB and the diagonals AC as shown. Also, you can add that one interior angle is 90. We know that all the angles of a square is equal to 90 degrees. So basically what we've done is you need to prove, I forgot to add that, all the sides or opposite sides are equal. So that means what you've done is you've been able to prove that the shape is a parallelogram. It's a rhombus, that's showing that all the sides are equal. And it's also a rectangle, showing that at least one of the angle is 90 degrees. The second option is to prove that all the sides are equal. And proving that all the four sides are equal, you need to show that the distance AB is equal to the distance BC, that's equal to the distance CD, equals to the last side AD. Also, you need to prove that one interior angle is 90 degrees. That is, if you find the gradient of AD multiplying the gradient of DC, that will give you -1, and that goes for the other angles. So in summary, for a square, you need to prove all the properties of a parallelogram, a rhombus, showing that the diagonals is perpendicular and they also bisect each other as shown, and then you need to prove that it's a rectangle by showing that one of the angles is 90 degrees. A lot of people prove that all the sides of the shape are equal and then they leave it as that. But remember, for a rhombus, all the sides also are equal, but the angles are not equal to 90 degrees. So basically, you must remember to prove these 3 points, that it's a parallelogram, it's a rhombus, and it's also a rectangle. Thanks for watching. Bye.